Please subscribe and you can download this code from description below. Title: Understanding Floating Point Precision in Python, Why does one get added at the end? Introduction. When performing arithmetic operations with floating point numbers in Python, you may encounter results with seemingly unexpected precision, such as having extra digits at the end. This tutorial will explain why this happens and how to deal with it. We'll use the example 9.89 plus 3.48 to illustrate the concept. Python's floating point representation. Python, like most programming languages, uses the IEEE 754 standard to represent floating point numbers. This standard provides a binary representation for real numbers. However, not all decimal numbers can be precisely represented in this binary format. Some decimal numbers have infinite binary representations, leading to rounding errors. Why does one get added at the end? To understand why 9.89 plus 3.48 results in 13.3700000000000001, we need to consider how floating point numbers are stored and how arithmetic operations are performed. When you add two floating point numbers, Python tries to represent the result as accurately as possible using the binary format. However, this accuracy is limited. Here's what happens step by step. 9.89 and 3.48 are initially stored as binary approximations. When you add these two approximations, the result is not exactly 13.37 in binary. To represent the result as closely as possible, Python uses the closest binary approximation, which happens to be slightly larger than 13.37. This is why you see 13.37000000000001 as the result. The 1 at the end is essentially the error or the difference between the true result and the closest representable value. Dealing with floating point precision. While these discrepancies in floating point arithmetic are inherent to the binary representation, you can manage them effectively. Conclusion. Floating point precision in Python can sometimes lead to unexpected results due to the limitations of binary representation. Understanding these limitations and using appropriate techniques like rounding or the decimal module can help you manage and work with floating point numbers more effectively. Always keep these considerations in mind when working with numerical data in your Python programs. ChatGPT. In Python, you might occasionally encounter situations where performing arithmetic operations on floating point numbers results in values that are not exact. This can lead to seemingly odd results like the one you mentioned, where 9.89 plus 3.48 produces 13.37000000000001 instead of the expected 13.37. This behavior is due to the way floating point numbers are represented in computers, using the IEEE 754 standard. In this tutorial, we'll explore why this happens and provide some code examples to demonstrate the issue. Floating point numbers in Python, and most programming languages, are represented using a finite number of binary digits. In the case of Python, it typically uses 64 bits to represent a floating point number, which allows for a certain degree of precision. However, not all decimal numbers can be precisely represented in binary form. For example, 0.1 in decimal is a repeating fraction in binary, which cannot be accurately represented using a finite number of binary digits. As a result, small discrepancies can arise when performing arithmetic operations on such numbers. Let's explore the issue through a Python code example. When you run this code, you'll likely get the output 13.37000000000001. This discrepancy occurs because the numbers 9.89 and 3.48, when represented in binary, are not exact. The internal representation of these numbers introduces a tiny error, and when you add them together, this error accumulates, resulting in the value 13.37000000000001. To deal with the issue of floating point precision, you can use the round function or format the output to display the result with the desired number of decimal places. Here's how you can do that. This code will produce the output, 13.37. This code will also produce the output, 13.37. By rounding or formatting the result, you can control the number of decimal places and present a more user-friendly and precise output. In summary, the seemingly odd result you observed when adding 9.89 and 3.48 in Python is due to the limitations of floating point representation. Understanding this behavior and knowing how to manage floating point precision can help you work with numerical data more effectively in Python. ChatGPT